All right, so now that our SageMaker environment has been set up and we have all of the data that the chatbot will reference organized within the source documents folder, we can jump to the next step. So we navigate back to our Bedrock POC folder, and we can exit out of the transcribed videos notebook since we finished that. Let's go ahead and pull up our chatbot_Udemy notebook. So as discussed when we were looking at the RAG diagram over here, the first thing we're going to do is index all of our documents living within our source documents folder. This index will contain all of the document's text and corresponding text embeddings in the form of a vector, which will then store in a Vectorstore for our LLM to later reference. So to begin, we'll go ahead and we'll instantiate our Boto 3 client in this line here. And then to create our documents text embeddings, we'll go ahead and we'll use the Amazon Titan text embeddings model right here. You may need to request access to this within the Bedrock UI, and to do this, pretty simple. You'll just search for Bedrock within console. You'll then pull up the base models. Scroll down until you see that Amazon Titan text embeddings model. Here it is, Titan embeddings G1 text. Hover over the embeddings model and a little sticky will appear if you don't have access. I do have access, but if you don't, pretty simple, you'll just request it, click into it, and you'll select Request Model Access. It should be granted right away. Once you get that model access, go ahead and jump back to your SageMaker notebook and go ahead and run that cell, and it should run for you with no issue. All right, next we'll go ahead and we'll run some more imports. And then this next cell here contains functions to load all of your documents within your source documents folder. It contains loaders for all sorts of document formats, and you can see all of the extensions that it supports within the loader mapping right here. Okay, so we'll go ahead and we'll load all of your documents within that source documents folder. And then we'll go ahead and we'll split the documents into chunks. We'll split the documents into chunks so that each chunk is stored separately within the Vectorstore. So remember, the Vectorstore contains the chunk's text and corresponding word embeddings. Chunks make sense because when we pass the LLM a question, the question gets converted into a word embeddings vector. A similarity search is performed over that Vectorstore, and it extracts similar embeddings containing the relevant text chunks to then help the LLM provide an accurate answer. We don't want to perform a similarity search over an entire document, especially if we have very long documents. Instead, we're looking to extract the more granular pieces of relevant context from those documents, which is why we break them down into chunks. At the end of this course, if your chatbot isn't performing as well as you expect or need it to, you can come back here and experiment with your chunking technique. Right now, I'm doing chunk sizes of 1,000 tokens. There's roughly 75 words within 100 tokens, with an overlap of 100 tokens between chunks. But this is something you can play around with and see how it impacts your chatbot performance. Maybe try smaller chunks, for example, 256 tokens, with maybe a 20 token overlap. I recommend checking out this Pinecone article that I linked to here, which discusses different chunking strategies. And remember, best practices in the industry are always changing, so be sure to research the latest techniques. All right, so we'll go ahead and we'll run this. And now that we have our chunks in this variable chunks here, we're going to go ahead and we'll create the embeddings for each chunk using the Amazon Titan text embeddings model that we just requested access to. So we'll create our vector store by passing the chunks and the Bedrock embeddings object, this method here, and we'll then save the vector store locally within our Studio instance as Bedrock index. All right, so let's kick this off. It may take a while to create the embeddings, especially if you have more documents. We only have 4 documents within our source documents folder, but if you have 1,000, 2,000 documents, even more, it might take upwards of an hour or so to run these embeddings. So once this has completed, you'll see a Bedrock index folder containing our vector store populate within your sidebar. At the end of this course, if your chatbot isn't performing as well as you want it to, in addition to playing around with different chunking techniques, you can also check out different embedding models. I've seen some articles floating around, like this one here, for example, where the Titan embeddings performance seems a little lackluster compared to other embeddings models. So you can see that's the Bedrock average. I recommend that you check out the embeddings models leaderboard here, and I'll link to this within resources within this section, to see which embeddings models are currently performing the best. So you can see they're all listed here, most of them accessible via Hugging Face or otherwise a private API. And if you want to try out a different embeddings model outside of Amazon Titan text embeddings, again, let's say your chatbot isn't performing well and you're really trying to make some tweaks and you decide to go with a more performant embeddings models, what you can do is you can go ahead and run this code down here. So what you'll do is you'll pick an embeddings model from Hugging Face. So you'll navigate back to the leaderboard and find a performant model that you want to use. We'll go ahead and we'll use this model here because it's public and free, even though it's ranked only about 50 on the leaderboard. So what we'll do is we will import Hugging Face embeddings. We'll copy the model name. So again, you saw all mini LM, L12V2. We'll go ahead, looks like we're actually going to be using L6, this one here, V2. We'll go ahead, copy that model name into your code, and then simply recreate your vector store using these embeddings instead of your Bedrock embeddings. We'll save it to our SageMaker instance, similar to how we did with Bedrock, and we'll save it as Hugging Face index. And once this code block finishes running, which again may take some time, you'll now see a Hugging Face _ index folder in addition to your Bedrock index folder. So you'll see here Bedrock _ index vector store and Hugging Face _ index vector store. So feel free to play around with different embeddings models. You can also use a top performing embeddings model, right? Ideally, you're not using one that's ranked 50, but one that's ranked maybe 1 or 2. And for example, like Voyage, right? Voyage is ranked number 2 right now. So just ensure you're using the relevant code. So here's an example if you want to use a private model, right? For private Hugging Face models, or if you want to use Voyage, ranked number 2, here's an example for the relevant code for that. So for private models, you would have to make an account with them and get an API key from them, whether that be Hugging Face or the Voyage website, and then you would just uncomment this code and run this instead. So this is for private Hugging Face models. You would import Hugging Face hub embeddings, and then your embeddings would use Hugging Face hub embeddings, and you would pass it your model name and your API token. If you want to use something like Voyage, you would make an account with Voyage, get an API key with Voyage, run this import, and then create your embeddings using Voyage embeddings, the model name that you want to use, and then your Voyage API key. And again, you would just pass these embeddings objects alongside your chunks to create your new and updated vector store. For the purposes of this course, we're going to go ahead and move forward with our Bedrock index vector store, but again, feel free to go ahead and play around with this. Now that our vector store has been created, it's time to move on to the LLM component.